So the next part of sampling and statistics in module 10, lesson 10.2 is all about making predictions. And our learning target, I can make predictions about a population based on data from a random sample. And the vocabulary that we are going to be learning is prediction. So, what is prediction? That when we can declare something beforehand, that is what prediction is. Okay. So, we are going to give an example of a sporting event. But please remember, if a survey is conducted about a population, it's got to be an unbiased sample. And then, if that is the case, then valid inferences can be made about the population. You can use those inferences to make predictions about the population. So let's look at this. Suppose you want to make a prediction about the percent of fans at a sporting event that are fans of the green team and the percent of fans that are fans of the blue team. Okay, because surveying everyone in the stadium is going to take a really long time. So that is why we take a sample that is representative of the population to help make a prediction about the population. So suppose two samples are taken at the sporting event. Okay, so you have green team and you have the blue team. And let's say the ratio of the blue team to fans of the green team from outside the stadium is 2 to 8. So the blue team was 8 and the green team was 2. So if it's talking about, excuse me, the green team was 2 and the green team was 8. So if you're writing the ratio of blue team to green team, this is going to be 2 to 8. And that is the ratio. 2 fans of the green team, of the blue team to 8 fans of the green team. Okay, so that is going to be my ratio of blue to your green. So let's say another sample is taken from the stadium seating section now. Okay, so inside the stadium. And inside the stadium, let's look at what the ratio could be. And suppose the ratio of fans of the blue team to fans of the green team in the stadium seating is also 2 to 8. 2 blue to 8 green. So therefore, over here also my ratio, you can write it as 2 to 8, which is, this is 2 is blue and 8 is green. Okay, you can write it like this, you can write it like this, or you can write it as 2 to 8. All right, so inside also I can see that I'm having exactly the same ratio. Okay, so this means that for every 2 fans of the blue team, there are 8 fans of the green team for this sample. All right, so this one is a part-to-part ratio because we are talking about the team with another team. So this is a part-to-part ratio which we have already done before. And in order to do a part to a whole, we can do that also. And a part to whole in this case would be what? You have the whole amount, which would be the 2 plus 8. And that would give me the whole amount. So this is part to part. Okay, this is part to part. But if I was doing a part to a whole, right? So then I would have the total amount of fans, which would be the fans of the blue team and the fans of the green team combined. And that would give me a total of 10, which is the whole. And let's say I'm doing blue team to the total amount or the whole, that would be 2 to 10. Okay, that would be 2 to 10. So in other words, what is 2 to 10? So the blue team would be 20%, right? So the blue team would be 20% of the fans. And so what would the green team be? And the green team would have been 8 out of the total amount, which is 10. So that is 80% of the population. Okay, so 80% is green team, 20% is blue teams. This is just an giving you an idea. Okay, now so let's see basically what is happening. 1/5 or 1 out of every 5 fans attending the event are fans of the blue team. If I simplify this, so 1 out of 5 fans are fans of the blue team. And these inferences are only valid if unbiased sampling methods are used. If biased samples are used, then these inferences are not valid. Okay, so let's do a problem with something like this. Okay, and let me erase this. Okay, so let's say I have to make a prediction about something from here. So we can say a high school athletic director is purchasing equipment for the athletic department in the coming year. In order to determine how much equipment is needed, the director randomly surveys 150 students. 150 students are randomly surveyed. Okay, randomly surveyed. Okay, this is randomly surveyed. Okay, now again, needed the director randomly surveys 150 students who plan to participate in athletics in the coming year. So the table is showing you the result of the students who were surveyed. Okay, and in this, as you can see, you have 36 students who chose baseball or softball, 30 chose basketball, football 45, gymnastics 12, tennis 18, and volleyball 9. Okay, so these are the 150 students that were randomly, chosen in order to answer the survey question. So now it's asking, how many volleyball uniforms should the director purchase if 500 total students plan to participate in athletics? Okay, so let's look at this and let's first find volleyball. Okay, so I can see volleyball is down here. Okay, so here's volleyball. That is 9 students. So we are going to do, when you're writing a ratio of students who plan to play volleyball to the total number of students surveyed, so it would be volleyball players, right, over the total students surveyed. Total students surveyed. And so how many volleyball players do I have? I have 9. Out of total students that were surveyed was 150 students that were surveyed. Okay, and then it's asking how many volleyball uniforms should the director purchase if 500 total students plan to participate in athletics. So we have the basic, which is given over here, 9 over 150, and we are going to set up an equivalent ratio or a proportion. Okay, and so what if 500 students is what we are looking at, if 500 total students plan to participate, what would be the amount of volleyball uniforms that the director had to purchase? So if I write it out like this as a proportion, I can make this simple for myself. If I simplify this a little bit, and 9 out of 150, if I divide this by 3, if I divide this by 3, what do I get? 9 divided by 3 is going to be 3. Okay, and 150 divided by 3 gives me 50. So I can do this. And we are trying to find out what is this volleyball number that we need for the people, volleyball uniforms, right? So Once again, I'm going to simplify, always makes it easier. So this is what? This is my volleyball uniforms that they are trying to predict that they need, okay? And this is my total number of students. Total number of students, okay? So once I write it out like this, 3/50, because the simplest is very easy for me to then find out how will I get the 500, okay? Because I know that 50 times 10 is going to give me 500. Whatever I do to the denominator, I do exactly the same thing to the numerator times 10. So that tells me that 30 is my answer, okay, because I'm going to multiply both by 10. So the director should purchase 30 volleyball uniforms. 30 volleyball uniforms need to be purchased. So this is a prediction that is based on the survey that was conducted, okay? Now, let's try another question. Okay. All right. So let's say I have, how many teens, the superintendent of a school district wants to determine the number of volunteer positions to have available for students. And so here is a graph, a circle graph. All right. So how often teens volunteer? How often teens volunteer? Okay. So let's say I have this is my few times a year, a few times a year. This is 22%. Okay, not at all. At 32%. Okay, then we have once a month at 12%. Okay, once a year at 3%, and once a week 29%. All right, so this is my graph. It shows the results of a survey where randomly selected teenagers within the district were asked, how often do you volunteer? Okay, so if the district has 2,000 teenage students, if the district has 2,000 teenage students, okay, about how many positions should the superintendent have available for students who volunteer once a week? All right, so again, we're going to make a prediction. While you do not know the number of teens in the sample, the circle graph shows the percent of teens who volunteer. And this percent is going to be once a week, this one, which is 29%. Okay, so this percent is a ratio that can be used for the sample. And the graph shows that 29% of students volunteer once a week. So 29% of 2,000 is what we are trying to find. And we can do this several ways, but we can, the proportion method is great because percent means what? That the denominator has got to be 100. So 29 over 100, write it as a proportion. So how much will it be over 2,000? Okay, and then that is, let n be the unknown part. So now all I'm doing is, okay, if I look at 100 and I look at 2000, I know that 100 times 20, right, times 20 is going to give me 2000. And whatever I do to the denominator, I'm going to do exactly the same thing to the numerator. So 29 times 20 is what I'm going to calculate in order to find this. And so I get 580 volunteers. Okay, so 29 times 20, and I get 580 volunteer positions available for students who volunteer once a week. All right, and let's do one last one for prediction. The manager of a movie theater wants to better predict how much popcorn to prepare each day, so that you can order the right amount for the people and have enough quantity for the people who may want to purchase popcorn. Okay, so every 15th customer was surveyed as to whether or not they buy popcorn, and 63% said they buy popcorn. Okay, so 63% said they buy popcorn. 63% buy popcorn. All right, and so this is definitely a random sample collection. It's unbiased, and if the theater expects to have 3,200 customers that day, all right, during the weekend, how many people are expected to buy popcorn? Okay, so they're going to have 3,200 customers. So they need to know, they need to make a prediction as to how much of the popcorn should we have so that we have sufficient stock. All right. So we can again write this as a proportion. And 63% means what? 63 out of 100 is equal to how many people should buy popcorn if you have 3,200 customers overall. Okay, so all I need to do, I know that 100 times 32 is going to give me 3,200. Again, whatever I do to the denominator, I do exactly the same thing to the numerator. So I'm going to do times 32. And then if I do 63 times 32, okay, and so I can see that 2 times 3 is 6, 2 times 6 is 12, and x is 0, 3 times 3 is 9, and 3 times 6 is going to be 18. And then when I add it up, I get 6, I get 9 plus 2, which is 11, carry over 1, 8, 9, 10. So 2016. So this X is going to be 2016. People will be buying popcorn over the weekend, at the movie theater. So this is a way to predict and make predictions about a population based on data from a random sample that is provided. All right. Have a great day, everyone.